computational biology, what ignited your passion for that? You've made a whole career of it. What was that first moment where you're like, wow, this is really neat. I think I want to pursue this?
I think the first moment probably was during my PhD. I think my project always was kind of working on plant in the mix of plant breeding and computational biology. I did my PhD at Texas A&M University, so College Station gets very hot. The cotton field, very hot during the summers. So I think that that's kind of where I decided that maybe I wanted to focus on the computational side of things. And I guess the group that I worked with kind of started to be able to shine a little bit in that space. So I was just guided that direction, which is good. My skin does not like the sun, so.
You get to stay in the air conditioning.
Very nice. I think all the computational people quite enjoy that. Although I love going to the field, so yeah. I think it's very important that computational people still spend time in the field just to make sure that you're keeping a foot grounded in that space.
Now, through computational biology, you develop predictive breeding strategies. What's your biggest challenge in doing that?
I would say our biggest challenge really is getting accurate data. So when we're trying to make decisions, we want to make sure that we're making those decisions with 100% fact. So making sure that we get correct information and then being able to do something with it in enough time. So making sure that we're collecting that data, getting in a place that we can use it, and then actually make that decision. I think all the tools are there, but we really haven't connected them in the way that we're able to do things all the time efficiently yet. But I think we're getting there.
What will be the secret, you think, to doing that, to connecting all those dots?
I think that there's a good community effort with the Breeding Application Programming Interface group called BRAPI that is trying to move things in that direction. It's just a ground-based, from the ground up building effort just to get different applications able to talk to each other seamlessly. So I think supporting efforts like that and then making a dedicated intent to actually connecting important pieces of software to get them to work together.
Now, what you do is really complex and technical, and how do you boil that down when you're talking to a non-scientific audience? Is that something you ever find yourself having to do?
We love to visit farmers and non-scientists, maybe young, blossoming scientists, and kind of try to have those discussions with them. Usually what we try to do is find some type of metaphor, I guess, for explaining things that we do in a less complicated way. Maybe like when we're doing genome assembly and that kind of thing, like we'll use puzzles, for example, and putting those puzzles together, whether you're a toddler kind of working with 10, my son is now 3, 48-piece puzzle. Whereas it used to be that we're putting together puzzles that are thousands or many thousands of pieces in the genomic space and kind of moving things to a way that we're making things simpler and simpler. So just finding some way that we can relate on the same level and explaining things at that level. But I think that for the most part, farmers especially are very familiar with a lot of the challenges that we face. And I think the conversations with them are really, really nice. We enjoy going out and talking to the farmers and stakeholders.
Breeding Insight On-Ramp project, can you tell us in a nutshell what that is and what's the biggest breakthrough that it's been responsible for so far?
So Breeding Insight On-Ramp is a partner project with the Breeding Insight group that's working through Cornell. So BI On-Ramp, as we call it, is really kind of the internal version of that project. And we're really working on that tool integration and bringing those tools to fruition, working with the breeding programs and what tools might make a difference in their programs. So one of the things that we've been working on is actually the Fieldbook application. So there's a nice component to Fieldbook that we've been working on and trying to stress test with those programs that we're working with, which is called geonavigation. So a lot of us use our phones and maps apps and those types of things with the internal GPS. We actually now can get external GPS I guess it would be like a unit, an external unit that we can correct, and we could tell the difference between like here and over here. And we can use that information through the app to actually get us to collecting the correct data points. So we're really kind of excited about releasing that geo-navigation tool in Fieldbook, working with the group that's been doing development on that and collecting accurate data points much faster with the groups that we're working with. So excited about that.
Yeah, looking forward to it. Thanks so much, Amanda.
Yeah, it's nice talking to you.